Hey, this is Ben Clary, and I'm going to go over my IQE number 2 revised for the final portfolio. So in this problem, we have a glass window, and we are giving the temperature of the outside of the car and the inside of the car, and then this plane of glass actually has a heat generation element in it, and we're given the thermal conductivity, the length of the wall, and the heat generation term. So what we can do is we can start from the differential equation, and we can find that the second derivative, we can set that equal to 0, and then we can take the integral twice to come up with two constants, and then we have to solve for those constants, and we use the boundary condition to do that. So when x equals negative L, the temperature equals the outside temperature, and when x equals L, the temperature equals the temperature inside the car. And then using that, we can solve for C. I used a lot of letters just for the first part, and then solved for the numbers later by plugging everything in. But eventually I got a temperature at a certain distance equation, and then I was able to plug everything in and solve for that temperature, which is 290.075 Kelvin. And for reference, the temperature inside of the car is 291.48, and so this is the temperature just before the inside temperature, so that makes sense generally for the temperature. And then the conceptual question is, if the temperature was the same inside and outside the car, what would be the warmest point in the glass? And this would be right in the middle of the glass, as this is a one-dimensional plane wall with a heat generation element, and the temperature would peak in the middle of the glass. So yeah, that's basically all I have to say for that.